This video on sign convention and lens formula is for class 10 ICSE students. There are many students who find this topic confusing. When to take the positive distances, when to take negative distances, which focal length is positive, which focal length is negative. And so in this video, I will break down these difficulties in sign convention and show you how to write the answers so that you will get full marks. And so the examiner is forced to give you full marks. To begin with, let us look at our lens formula. Our lens formula says 1 upon f is equal to 1 upon v minus 1 upon u. Now you need to remember this formula by heart. Now there are certain rules for the distances. Number 1, all distances are measured from optical center. So this is our optical center here. This is where you will start measuring all the distances. Point number 2, the direction of the incident ray is positive. So where the ray comes from the object, that ray will be considered as in positive direction. Point number 3, object always is placed above the principal axis and that is considered as positive. So as of now, just focus on positive and positive direction. The direction of the incident ray is positive and the object, the height of the object which is above principal axis will be positive. So which means anything that is opposite to the incident ray will be negative, and if the image is below the principal axis, then it will be considered as of height negative. And if it is above the principal axis, then its height will be considered as positive. Now I shall tell you a simple trick to remember which quantity is positive and which quantity is negative. So if the object is here, this is our incident ray. Now the direction of the incident ray, that will be positive, which means anything that is formed here, the image which is formed here, the distance of the image, if the image is on the right, it is going to be positive. But where will we keep the object? The object will be here, correct? Because the incident ray will come from the object. Now, the object distance will be measured where? From the optical center. Where is the optical center? Here. So you have to start measuring in this direction. So when we measure this way, the object distance, which is denoted by u, that u will be negative. But if the image is formed somewhere here, this image, you will measure its distance from O, means in this direction, which is the same direction as the incident ray. So that becomes your positive distance for the image. So the image distance, which is V, is going to be positive. All right. Let us look at the focus for convex lens and concave lens. Now, if the ray of light is parallel to the principal axis like so, on a convex lens, you will have the rays meeting this way and this way. So, this is your principal focus, and this distance you will measure from O this way. So this is your focal length. So you will have a focal length for convex lens. That is going to be this side, means in the direction of the incident ray. So that is your positive focal length. But if we want the focal length of the concave lens, the object will be somewhere this side. So from the object, we will have the incident ray coming this way. So this is going to be positive direction. Now the ray that comes this way gets diverged and it appears to be coming from this point. So we will have the refracted ray here, and this will be the principal focus for the concave lens. Now the object is this side. The direction this way is positive. That means this side will be positive distance, and object distance, let us say the object distance is measured from here. If this is your AB, which is the object, then we will measure the object distance from here this way. So the object distance will be negative, and the focal length will be from here, from O we will measure, so that becomes negative focal length. So the focal length is negative. Focal length is negative for which lens? Concave lens. So what did we learn? That if it is convex lens, the focal length is going to be positive. If it is concave lens, focal length is going to be negative. Okay, now the simple trick for you to follow is just this. Let us say that this is our principal axis and this is our lens. Okay, now if you consider your object here this side, this is your object, then the incident ray will come this way. In that case, the direction this way, anything this side, because this is our O, we will measure on the right hand side, we will measure the distances from here. And if it is on the left hand side, then the object distance, we will look this side and we will start measuring from O. So this is going to be negative. Okay, so your object distance here is going to be negative. Your image distance, if the image is on the right side, it is going to be inverted image, and the image distance you will take from O this way. So you will go positive, correct? Now the object is above the principal axis, and so the height of the object will be considered above, means positive. But if it is inverted image, then the image will be considered negative because it is shown below the principal axis. All right. So now these are the basic rules. Now the simple trick is just this. You consider this and this as the vertical axis, and this principal axis you consider as your x-axis, which is horizontal axis. Now if you look at the coordinate system, this is the origin, and this side you have the positive values, this side you will get the negative values. This side above, it's going to be positive, and below it's going to be negative. So you just keep this in your mind, and remember that the object will always be kept on the left hand side. Now I can also say that if the object is placed here, then if this is the incident ray, then this is going to be your positive side and this will be your negative side. But this is going to confuse you. So no matter what your numericals are, keep your object on the left hand side. So left hand side means the object distance from here to here, that is going to be U. U is going to be negative. All right. If the image is real, it's going to be this side, because after refraction, the rays are going to meet on the right hand side. So the image distance will be this side, that will be positive. If the object is above, then above, if we go this way, it is positive height. And if the image is inverted, then it is going to be negative height. All right. Now, if I have a virtual image, what happens to the virtual image? The virtual image is going to be sometimes this way and sometimes it will be this way. If it is magnified, then this lens has to be the convex lens. If, let us say, the image is diminished like this, then this lens will have to be concave lens, because concave lens will always give virtual and diminished image. Okay. So if it is upright image, then the image is going to be positive because it is upright and it is above the principal axis. This one also image is upright, which is above the principal axis. So that will be positive. So you will see that the height of the image is going to be positive in case it is a virtual image. Okay, now where is the real image formed? If the object is on the left hand side, on the right will be the real image. Now if it is the real image here, it will always be inverted. It can be this way or it can be this way, correct? So inverted means your height of the image will be negative. So remember, all you have to do is remember the simple coordinate system. This is the simple trick for you. You keep the object here this side. The object will be on the left hand side. Then from O, you'll measure object distance. So your U is going to be negative. If you are measuring distance on the right hand side, for the image distance here is going to be positive. Just like the number line. This side if you go, it is positive. From here, if you go this side, it is negative. If we are looking at the height of the object which is placed above the principal axis, this will be positive and this will be going below. So that will be your negative height. Okay, with that in mind, let us look at a simple question to understand if we have remembered everything. Our length formula is 1 upon f is equal to 1 upon v minus 1 upon u. Now let's take an example. Let us take a convex lens and let us say that its focal length is 10 centimeter. And we are placing the object in front of it at 30 centimeter distance, and you have to find where is the image formed. All right. Now look at the sign convention. Keep this in mind. This side it is positive distance, this side it is negative distance, this side it is positive height, this side it is negative height. Got that? Now focal length for the convex lens, the rays come this way from the object and they meet here this side. So your focal length is going to be positive. Object is kept here this side in front of it. So remember, this side where the object is, that is called as in front of the lens. Now in front of the lens means from O you will measure this way, means it will be negative. Now we have to find out what is the image distance. So let us substitute in this. 1 upon 10 is equal to 1 upon v minus 1 upon u. U is minus 30. So that gives us 1 upon 10 equal to 1 upon v plus 1 upon 30. So 1 upon v will be equal to, take this that side. So it becomes 1 upon 10 minus 1 upon 30. LCM is giving you 30. 10 3 is 30. Therefore, the image distance is 15 centimeter and it is positive, which means the image is going to be this side, means it's going to be real image. If it is real, it will also be inverted image. Okay, so did we understand how to use the lens formula using the sign convention? So we stop our video here. To all students currently in class 10 this month, that is January 2023, I have been aggressively solving sample papers with my students, and because of this, the entire syllabus has been covered multiple times in my sample papers course, which is available at a discount to the first 100 students who click on this link. I look forward to helping you secure maximum marks in physics, chemistry and mathematics. Join today to avoid stress at the last minute. Lot of time has already been lost. Take action today.